In Module 3, Lesson 3, we're going to be talking about adding fractions with unlike denominators. And in order to solve these, we're going to be using visual models representing our whole and using those visual models to create equivalent fractions. We will be working with the fraction 1/2 plus 1/4 equals blank. In order to solve this addition equation using the visual models, first, in step 1, you want to draw your rectangular fraction model for each of the fractions in your problem. Your first fraction, you want to use vertical lines, meaning up and down. For your second fraction, you want to use horizontal lines, meaning right to left. So my first fraction is 1/2, and I'm going to use vertical lines. So I know in 1/2, my number of parts is 2, so I have 2 parts. And out of those 2 parts, my numerator is 1, so I have 1 of those parts. For my second fraction, 1/4, I'm going to draw horizontal lines, and I know that I'm going to want 4 parts because that's my denominator. So I'm going to do my best to create 4 equal parts. You want to do your best. I know they're not going to be perfect, but you want to know and get them as close as possible to being equal so that your mind can connect that the parts are equal. My numerator is 1, which means how many parts I have. So I'm going to color in 1 of my 4 parts to show my 1/4. So I have 2 rectangular fraction model representations for my problem. For step 2, I want to partition my wholes for each of my fractions into equal fractional units or like units. And remember, when you partition something, that means you're making smaller units. So I'm going to take a look at my 2 rectangular fraction models and say, what can I do to both of these to create equal units in both? A lot of times what you want to do is you want to take the line you have from your first fraction and add it to your second. And then take your lines from your second fraction and add it to your first. So now I want to take a look at and make sure that I have equal units in 4. Here I have 1, 2, 3, 4, 5, 6, 7, 8 units in my whole. And over here I have 1, 2, 3, 4, 5, 6, 7, 8 units in my second whole, so that they are equivalent amount of units. Step 3 is to rewrite the addition sentence using the new equivalent fractions that you've created with your rectangular fraction models. So in my first fractional model, there's 8 parts, so I would write my denominator as 8. And then I ask myself, how many parts do I have? 1, 2, 3, 4. So I have 4 of 8 parts, or 4/8, and I'm adding those parts to my second fraction, which is also 8 parts, and I have 2 of those 8 parts, so 2/8. Step 4 is to solve. It is very important here to remember your whole. I'm going to use our fractional models up here to show representation. This is like saying this whole right here plus this whole right here equals what? And our whole is one rectangle. And so we want to remember that our whole doesn't change. We don't have 2 wholes now. Our whole is still the same. We're just taking parts of these 2 wholes and putting them together into one new whole. And so when we do that, we want to make sure that our whole has the same amount of parts as our 2 wholes before, which is 8. So I'm going to make sure that I have my 8 wholes. And then I take my parts from this one, which is 1, 2, 3, 4 parts. So I take 1, 2, 3, 4 parts from my original fraction, and I add in my 2 parts from the remaining fraction. 1, 2. And I'm not changing my whole. My whole is still 1 square. So if you look at this representation of my whole, my answer is 8, because that's how many parts my whole has, and I have 6 of those 8 parts. And you want to think about why, or a conjecture on our denominators remaining the same when we're adding. Why is that? How could you justify that those denominators remain the same? And it all relates back to what is my whole that I'm solving for. And finally, step 5, you want to ask yourself, can you rename your answer to a larger fractional unit, meaning you're changing these small fractional units into something bigger, which equals a smaller denominator in your answer. So in order to do this, you first draw your model for the answer, which we've already done here, 6/8. And you ask yourself, can you make that model into less parts that are equal? And that means removing some lines. But you want to make sure that when you remove those lines, that all of that part or that unit is still colored in. Because I can't remove these lines here because my half is not all colored in, if you see what I mean. Because this half is not all colored in and this half is not all colored in. So you want to be very careful in how you take away lines. I could try removing this middle line and see if all my fractional parts are still colored in. Let me recreate those. So I've made my model into 4 parts now, and if you look, they're colored in all the way across. If I just fill in right here where I did the lines. And so that whole fractional piece of the model is colored in so that they can be equal. You can't have part of a fractional model colored in, otherwise it's not an equivalent fraction unless you can rearrange them to make it equivalent. So I've removed that middle line, and now I rename to my equivalent fraction, which is, I'm going to put another equal sign here because these are all equal or balanced. My new number of parts is 4, and I have 3 of those parts. So 6/8 is equal to 3/4, equivalent fractions. And you can also think to yourself, what did I do to 6/8 to equal 3/4? They're equivalent fractions. The same amount of space is colored in or taken up in each of those fractions, so they're equivalent. So what did I do to get that 3/4? And we know from our conjecture that if we're making equivalent fractions, we have to be either multiplying or dividing by 1. And in this case, we're moving to a smaller answer, which means that we will be dividing. So what did we divide 6 by to get 3? And that's 2. And we have to remember that if we want to create that whole, our numerator and our denominator have to be the same. And if you look, 8 divided by what equals 4? And it's 2. So in order to create this 3/4 equivalent fraction, I divided my answer by 2/2 which is also equal to 1 whole.